Welcome to yet another class. I'm Dr. B, and today we are going to take ourselves through simultaneous equation in chemistry. How do we apply simultaneous equation in solving chemistry problems? So we're going to talk about simultaneous equation, simultaneous equation in chemistry. Simultaneous equation in chemistry. That's what we're going to look at. So we're going to see how do we solve chemistry problems using simultaneous equation. We're not going to waste ourselves much time. We'll just take a good look at the first example, which is a mathematical problem. Simultaneous equation in mathematics, solve it. Then see how we can apply it in chemistry. Now, we have a mathematics problem here. Maybe let's say we are given y plus x equals to 1 and 2y minus x equals to, let's say 5 and 1. Let's use numbers that will be a bit easy for us to understand. Now this is equation 1 and this is equation 2. How do we solve this simultaneous equation in mathematics? We first have to understand how we can solve it in mathematics and see how we can apply it in solving a chemistry problem. Okay, now for this question that we have here, there will be need for us to do what? To get an equation 3, which can allow us to be able to solve and get the two variables which are y and x. And to get equation 3, you can use any of these equations to get equation 3. So we are going to use equation 1, being that it's quite easier to have used equation 1 than equation 2. Now we will say from equation 1, okay, we'll get equation 3 by making any of the x and y the subject of the formula. If you want to use make y or x, it depends on what we want. Now for this, we are going to use x as the subject of the formula. So we will say now that x is equals to 5 minus y. This gives us equation 3. Why the minus y? Because we are pulling plus y out from, across the equality sign to this side of the, to the 5, the right hand side. So we change the plus sign to the minus sign. If this is equation 5, what do we do with equation 5? What we simply do there is we substitute wherever we see x in equation 2 with this. This is because we have used equation 1 in getting or obtain equation 3. We cannot substitute into equation 1 again. We substitute now into equation 2. So anywhere we see x, we are going to move 5 minus y into that place. So we now have what? We say we substitute what? We substitute equation 2 for what? Equation 3. Equation 3. So that means that we will have what? We will have 2y minus x is what? 5 minus y, okay, is equals to 1. That's what we'll have, because we have decided to replace x with 5 minus what? 1. And when that is done, we could open the brackets. So if you open the bracket by expanding, you have 2y minus 5. Minus times minus is plus y equals to 1. At this point, we do what? We collect like terms. And to collect like terms here, it means we are going to say we have 2y plus y is equals to 1. Take this to this side. The sign changes to plus 5. So we can solve. 2y plus y is 3y. And 1 plus 5 is 6. So we can have what? 3y is equals to 6. We are looking for y. So we divide both sides by 3. So this will cancel this. This will cancel this. Y will now give us what? Will now give us 2. We have been able to obtain the value of y. How do we obtain the value of x? Because for a simultaneous equation, you have two variables, x and y. For us to obtain the value of x, we'll substitute the value of y equals to 2 into equation 3. You can actually substitute this value to any of the equations. and get the right answer. But for purpose of accuracy, it's always good that since you have used equation 1, you have used equation 2, you have to use equation 3. So we substitute y equals to 2 in equation what? In equation 3. Now, this means that our equation 3 is what? X equals to 5 minus y. That's our equation 3. So where we see 5 minus y, we put what? 2. And then x will be equals to what? 3. That means when x is equals to 3, y is equals to what? 2. Now, in this way, you have been able to solve for these two variables through a simultaneous equation. You have gotten the value of x and y in these two equations. How do you do the same thing for a chemistry problem? Join me. Now, if you had a chemistry problem, let us say that we carry out an experiment in the lab, a spectroscopic experiment, spectroscopy, where a compound is used. And when the experiment was handled, there were 2 fragment molecules that were obtained. Okay, the 2 fragment molecules that were obtained came with their different masses. Okay, let us say that in a spectroscopic experiment, okay, 2 fragment molecules were obtained. So the first fragment molecule that was obtained had an empirical formula. Let's say CH3 is empirical formula with mass 6 AMU, and the second fragment molecule has an empirical formula C2H4 with mass, let's say 10 AMU. Okay, the question now is calculate the mass of. So the question now is what? Calculate mass of what? Hydrogen and carbon atoms. See, this is a chemistry question. Okay? In a spectroscopic experiment, there were 2 fragment molecules that were obtained. And the empirical formulas are CH3 with a mass of 6 AMU and C2H4 with a mass of 10 AMU. Calculate the mass of hydrogen and carbon atoms. You can only solve this problem amicably using simultaneous equation like we did in mathematics. Now let us apply simultaneous equation and see how this works. Alright. Now, if we apply simultaneous equation, let's see how it works. Now, I want us to know that we are going to use this empirical formula and this one to obtain our equation 1 and equation 2 as simultaneous equation. This means there is 1 carbon atom here, 3 hydrogen atoms here. So it means that for equation 1, we have carbon plus 3 hydrogen is equals to 6 AMU. And for the second one, we have 2 carbon plus 4 hydrogen equals to 10 AMU. This is our equation 1, this is our equation 2. That is how you break it, if you have to use simultaneous equation in solving it. So, using the idea we already had from the mathematical point of view, how do we do this? We'll look for what? Equation 3. So we will say, from equation 1, okay, we'll obtain equation 3. So we make C the subject of the formula. So we have what? C is equals to 6 minus 3H. This is our equation 3. Just like we did in the mathematical part of it. So you have this. Now what do? We substitute equation what? 3 into what? Equation 2. Because we said we use equation 1 in obtaining equation 3. So we rather substitute equation 3 into equation what? 2. So it means that wherever we see C in this equation, we are going to substitute that. So it means we'll have 2 bracket 6 minus 3h, which this is C, plus 4h is equals to 10. Open this bracket. 2 times 6 is 12. 2 times 3 is 6h plus 4h equals to 10. What do we do next? We collect like terms. So we have here as minus 6h plus 4h equals to 10 minus 12. Because plus 12 has moved to the right hand side. So at this point, what are we going to have? Minus 6 plus 4 is what? Minus 2h. 10 minus 12 is what? Minus 2. So we can look for h by dividing both sides by what? Minus 2. So we look for h by dividing both sides by minus 2. So that means that we can possibly say minus 2h divided by minus 2 is equals to minus 2 divided by minus 2. This would all go. So, therefore, h will be equals to 1. Now we have got the mass of hydrogen atom. How about that of carbon atom? What we simply do is to substitute this value for h to equation 1 or equation 2 or 3, but more preferable equation 3. So we do what? We substitute we substitute hydrogen equals to 1 for what? Equation 3. And this is equation 3, which says C is equal to 6 minus 3h. That's equation 3. So anywhere we see h, we put 1. So C will be equals to what? 6 minus 3 times 1. And C will be equals to what? 6 minus 3. Because 3 times 1 is what? 3. And then C therefore will be equals to what? 3. That means that when hydrogen is 1, carbon is 3. So it means that in the entire spectroscopic experiment, 1 atom of hydrogen and 3 atoms of carbon were involved in that experiment. You can see how comfortable it is to answer that question in chemistry by applying simultaneous equations that we have in mathematics. I'm sure you've learned something beautiful from here, and you would like to apply simultaneous equation in solving some other chemistry problems. Until next time, please do not forget to share, to like, do not forget also to subscribe, do not forget also to go to my YouTube channel and do the subscription. Leave your comments there in form of questions or otherwise. They will all be attended to. Don't forget also to share. Until next time, it's bye for now.